Okay, we're looking at the extension problem from the algebraic fractions mini test. Yeah, this is quite a nice question to get your teeth into. The issue is you've got to be really careful that every single factor is correct and you don't sort of switch any negatives round just because you don't want them to be there. So first thing we're going to do is just look fraction by fraction at all of those quadratics and see if we can factorise them. So let's start with that first fraction. So in that numerator, I've got the difference of two squares. That denominator does factorise. I'm going to assume they probably do all factorise. So that denominator factorises to x minus 6, x minus 5. So I'm going to be able to do some cancelling there. I'll leave it for now. So again, I've got the difference of two squares, but just be really careful. So that's going to be 5 minus x, 5 plus x. You could take a negative factor out. So if you preferred, you could have maybe said that that's minus x squared. Sorry, so that'd be minus, wouldn't it? Minus x squared minus 25, and then said so that's minus x minus 5. X plus 5, that would have been equally fine for factorising that numerator. Okay, didn't mean to do that, right. Okay, so I'm going to leave that second denominator as it is for now. And then I've got 6x squared, yep. So you could with these, if you're not happy factorising when there's a coefficient in front of the x, when the x squared has a coefficient, you could get the solutions from your calculator and work back from there. And let's see, so it's got to be 3 and 1. So what is going to work? I think if I had, so 6 and 1 won't work, so 3 and 2, yeah. So if I do 3x there and 2x there, that will give me my 6x squared. And then if I make it plus 9x minus 2x, that will give me the 7x. Okay, and then I've got that denominator to factorise. So this is a little easier because obviously 3 is a prime, so it has to be 3x and x. So I'm guessing that it is going to factorise to 3x minus 1 so that I can cancel with that numerator. So if it was 3x minus 1, that would be x plus 6. And then I would get 18x minus 1x. So I would get the 17x. Okay, I'll come back. Right, okay, so now let's just see what immediately cancels. So an x minus 6 and an x minus 6 cancels. Oh, sorry, apologies. That's wrong, isn't it? Sorry, that should be, because I'm talking and writing, that should be x minus 6, x plus 6. Right, which is handy because then that means that, so I can, oh, for goodness sake, sorry. Probably start this again, but I won't. Right, so that was a multiplication. Okay, get them in the end. So yeah, so because I'm multiplying all these together, I can cross cancel across any of these fractions. So that x plus 6, I will cancel with that x plus 6. The 3x minus 1 can cancel with the 3x minus 1. And I just need to be really careful when I'm looking at this, because x minus 5 doesn't actually cancel with either of those, although they do look quite similar. So this is where actually, if you had factorised it as I did in red up here, you'd be in probably a slightly better position at this point because the x minus 5 and the x minus 5 does cancel. So this is where, this is sort of part of what makes this a good extension problem is every stage of your working would have to follow through. So let's just rewrite these fractions without the cancelled factors. So that first fraction, I've only got the x minus 5 in the denominator. So what I am going to do is I am now going to take a negative out as a factor of this next numerator. So if I take a factor of negative 1 out, then 5 minus x does become x minus 5, and I'll leave the 5 plus x alone. And all I've got is the 2x plus 3, so that I could write that as 2x plus 3 over 1 just to keep it as a fraction. You don't have to. Okay, so now I have clearly shown that they do cancel. So now all I'm left with is, I've just got to be careful I don't forget about that minus. So my numerator, I've got 1 times minus 5 plus x. I'm going to write that as x plus 5. It's not essential, but I think that's just probably how we're more used to having our brackets written, and then multiplied by 2x plus 3. And that is all over ax squared plus bx plus c. And if I go back to the original question, they told me that should equal x plus 5 over 6 minus x. So there's a few ways I could then deal with that to find the three terms of that quadratic. I can cancel through both sides by x plus 5, again being really careful that I don't lose that minus. And then I think probably what I would do is multiply up. So I'll write that stage out. And then I'm just going to cross multiply. So I'm going to multiply up by the 6 minus x and up by that quadratic. So basically, if I now expand that left-hand side out, I've got the full quadratic that I needed. So I just want to be careful with those negatives. So it's going to be, so what will I do? I'll keep the negative there and then just multiply through by that at the end. So I've got minus 2x squared. I'm going to have 12x minus 3x. And I'm going to have plus 18. But then when I get rid of the brackets, when I multiply through by that negative, that will actually end up as 2x squared minus 9x minus 18. So that should be fine, but let's just really clearly say, so that means a is 2, b is minus 9, and c is minus 18.